make a note to look at the question though. Question number 7. You're telling me you can't find a right answer?
It's in part 25.
Can anybody find a right answer?
Google says part 25, that is for commercial aircraft. It is
Well, that's
in
what
part
it is.
23.
It is in part 23?
You got a RTA.
What?
I will, I'll look. I think it's in there from last year,
I don't believe you.
but
That's so hard.
we will see. All right, I'll come back tomorrow with that answer, for sure. All right, back to PowerPoint number 1. I'm going to go back a couple slides, and you'll just have to ignore the red on there. But when we're dealing with, I'm going to back this up and say my fault for not teaching it well. Thought I taught it well, but there's enough confusion, it's my fault. Both of these are ammeters, right? They're both reading amps, which is an ammeter. I don't know why they don't put the P in. I don't like it. They stopped at am, and then they finished off with meter instead of saying ampermeter, because that would be a mouthful. So they're both ammeters. This one is a state of charge ammeter, which is going to be connected between the battery and the bus. It's going to tell you if you are on the positive side charging your battery, if you have power going back into the battery, or if it's on the negative side, if you're discharging your battery, putting power into the system, which is a little bit like in your head backwards, right? If it reads negative 30, what am I doing? Well, you're discharging 30 amps from your battery is how that reads. So they're both ammeters. This one's a state of charge, and it just tells you what you're doing to your battery. So normally when we're flying around in a stable condition, electrically it points at 0 because our alternator or generator is what's actually producing the power, and the battery's just there going, I'm along for the ride in case you need me later. This ammeter, which is called a load meter because it is on the line between the alternator and or the generator and the bus, just reads what that power making device is outputting. So if I go to a couple pictures here, this one is a Piper product, to say, Piper Aero. It is cleaner on my slide, and this is updated from the end of PowerPoint number 1. So if you ever wanted to go look at it, look at the clean version, just go back into 1, and I bet I didn't open it yet, so I'll do that when we do our first break. Open PowerPoints. Otherwise, you can look it up in the wiring diagram. I highlighted some stuff because it's hard to see. Here's our battery, here's our alternator, here's an ammeter, and you got a starter out to the bus. So if you're going to follow the power through this thing, from our battery, you're going to have to close the battery master, and then it can feed the bus, and then your components. I don't see anything about an ammeter on there, so there's no state of charge on this aircraft. From our alternator, the power goes through an ammeter, through a diode, and that's going to go, where'd that line go? Maybe I got the bus. There we go. To my bus. So, what would I call that ammeter if I don't want to call it an ammeter? I'll just take volunteer. Load, yeah, because it's telling us the load on the alternator, right? How many amps are coming out of the alternator, feeding our system. This is the typical Cessna product. I believe I pulled out of a 206. On the Cessna, you got your alternator. Your power comes out straight into the bus, and off the bus, you can feed all your electrical equipment. So we don't know what our alternator is doing as far as amps go. We just know if there's a voltmeter, which there typically will be on a Cessna, we know, hey, are the volts at 12 volts? Not really doing anything probably. Or is it 14 volts? Oh, my alternator's probably working because I'm at that little bit higher range. On this one, where's my battery? There's my battery. Battery through my ammeter, what would we call this one? State of charge ammeter. Through my state of charge ammeter to the bus. So, if you had an alternator that's rated at 50 amps, if we're at a low RPM, my 50 amp alternator is probably only going to be producing 30 amps. And if I was to kick on enough load that I needed more than that, in this picture I might have 30 amps coming through my, there's the other way around, sorry. 30 amps coming through my alternator out to my load, and I'll go with 15. So my total usage could be 45 amps, but I'm draining my battery. That amp meter then would be in the negative, right? That state of charge is going to say, hey, you're draining 15 amps at the moment because I'm not able to keep up. Now once I get to cruise speed, my alternator is going to go probably up to full output. It would get to a 50 amp output, let's say. And if I'm only using 45, I'm going to be sending probably 5 amps back to my battery to recharge what we just used. So now my amp meter is going to be saying, hey, oh, that was good. It's going to be saying, yes it did. Like your light flashing before your eyes. Hey, we're recharging our system. So, making sure that you understand the difference between those two is important. Now, as long as our battery works and is good, let's say I have an intermittent load. I'm cruising along, I'm at almost max amperage for my alternator because, I don't know why, because I put a glass panel in and I'm using a bunch of power. I go to use the flaps or landing gear or something. If I exceed what my alternator can produce, there's kind of two things that are happening at the same time, and it gets hard to kind of split them out. But basically, the alternator is going to be like, I'm trying to make the power, but I can't. If the battery was bad, what would happen is the alternator is going to be like, I'm trying, but the voltage is going to start falling off, right? Because he's trying as hard as he can, but he can't keep that amp flow up at that voltage. He's just not capable of it. So the volts start falling off, and if you let that go long enough with enough load, we can overload our alternator to pop a circuit breaker if we let that happen. So it does max it out, and if we keep adding amps to it, it'll be like, and it can overload and possibly pop the circuit breaker. What happens in reality is we got a battery in there. So as we add extra load, our alternator is like, I can't quite keep up, and the voltage starts dropping, let's say from 14.7 volts down to 13.5 volts. Well, we got a battery here that's been sitting there at 14.7 and goes, I got a little extra capacity for you, I'll help you out. So we got some amp draw coming out of the battery. So that's how that shared load basically happens, is after our alternator can't quite keep up anymore, I can't quite do it, the battery's like, well, I got some voltage here. Now, in a perfect world, our voltage isn't going to drop all the way down to 12, right? That'd be a problem. But if you think of it that way, that's what's going on in the system with a alternator that we say it's hard to over-amp it. For instance, if you're looking at your load meter gauge, pretty rare you're actually going to exceed 100, because most of our alternators, they'll only give you a certain amps, and they're like, that's pretty much what I can give you. I can't go much. So as long as the battery is working, you're pretty much not going to exceed this thing, because the battery is going to pick up where it's leaving off. Where it comes into that prepware question of don't exceed 100, in reality, it's going to be more like, I'm at 50, let's turn another load on. I'm at 70, let's turn another load on. I'm at 95. I don't know if I got enough for another load. Because if I keep turning them on, my battery's going to pick up. So just the way it's phrased, don't exceed 100, well, how would it go over? And or on a twin engine, or if the battery can't keep up. So it's, the more I dug into this question and talked to Dean, I'm like, these type of aircraft, gonna be pretty rare to actually see it exceed because our battery's gonna pick up that extra load. So that's how it's gonna work in practice. Question?
So if your alternator, whatever, putting out like 50, and
Yep.
your whole system needs 45, and your battery's charging, where's the extra?
The alternator then would, basically what would happen is the alternator would be saying, oh, I can do 50 easy, and the voltage starts getting higher, and then our voltage regulator says, whoa, back it off a little, buddy.
So then it would just go
And
back
backs
down.
the voltage back down, correct, yep. So that's what we're adjusting when we adjust the field voltage on our alternator, which we'll talk a lot more later, is the field voltage is gonna say, I want 14.7 volts. And if our amperage use starts going up to where it needs more power, we're adjusting that. All right, so quick review on this one. If you have a load meter, you're reading the amperage coming out of the alternator going to the system, that airplane, you don't know if the battery's charging or discharging. So it's kind of interesting. You might have a voltmeter to be able to see, hey, am I up at my 14.7 or not? But yeah, so in a perfect world, me and Dean both agreed, you should have a state of charge meter, and you should have a load meter, and you should have a voltmeter. And it'd be nice if they gave you a fourth one that gave you total load, but all that adds weight and complexity. On a glass panel, you probably do, but a lot of the equipment we're working on is not glass panel, so we don't. All right, makes sense? Does that kind of clear stuff up a little bit?
Real quick, if you're going over your load that your alternator can handle,
Yeah.
and you're stealing some from the battery,
Yeah.
and different stuff, you would still see a voltage drop if you have more.
Yeah, you'd see a slight voltage drop as we start eating into the battery's voltage. Because the reason power is coming from the battery is the battery was sitting there at 14.4 charged up, and now the system's lower than that. So the battery's like, I got more pressure than you got. Let me give you some of my pressure.
So it's not like the battery kicks in and it goes back to your full
No,
voltage,
no.
because the whole point is you have more
Yeah.
load than you can handle.
Yeah, because voltage is pressure. So the alternator, if you thought of it like a balloon, this is a bad picture, maybe a capacitor's better, but the alternator over-pressurizes our battery just slightly, if you want to phrase it that way. And if the alternator can't quite keep up, that battery's sitting there with that extra pressure to say, well, I'll help out. Okay. All right. Good. Let me erase that. Get that open. And erase this. I'm glad Mr. Tanner could come in today. Good to hear from him. I almost signed up. But I don't want to say I'm too old. I just, with my wife's situation, I can't. Sometimes I'm jealous for you guys. Because you get to my age and you just have less opportunities. It's a thing that happens. So that's one of the things I'm excited about being a SMAT, though, is I get to train people to possibly sign up with telemissions. So pretty cool. When I was sitting in your spot, I sat next to Ernst Fuhr. I told you a little bit about Ernst. Ernst was an air traffic planner. Is that the right word? For Swiss, was it Swiss Air? They're one of the big airlines. I think he worked in Switzerland. Anyway, he would plan their routes. He'd look at the weather and figure out if the jets could fly this way or if they should fly that way. I guess somebody has to do that even for the airliners. So that's what he did. Got connected with Telemission, got his helicopter rating, came to the U.S., put, I think, a couple of years in trying to get hours. He was actually flying sightseeing tours in New York City, which, I mean, I don't mind flying in the jungle, but sightseeing tours in New York City, that seems sketchy to me in a helicopter. Because, like, if your engine dies, where do you go? At least in the jungle, it's just you. Just saying. In New York City, it's New York City. So he did that for a couple years, and then Telemission said, okay, well, you need to get at least some maintenance training. He was a helicopter pilot, racked up a bunch of hours doing sightseeing tours, stuff like that. Came to SMAT for maintenance training. He's, I don't know if I'm recording, colorblind. The only place in the world he could fly with Telemission, my understanding, is Madagascar. So even like on this path, something about Madagascar, you could get away with being colorblind. so he was on a very narrow path. Put a lot of years and a lot of time into being called or having the determination to fly helicopters with hollow mission in Madagascar. So it was really fun to see that video of the helicopter going over, because I'm like, that's Ernst, that's my buddy that I rebuild engines with, flying helicopters in Madagascar. So anyway, glad he could come in, and even more glad you can see this American video too. I think we do similar work. It's funny when you watch theirs. Were they 10 helicopters? Or 9 in one? Yeah, they got a lot of equipment. A lot of equipment going on.
I don't know if that included the yellow.
Yeah, it's hard to tell if the yellow one was really yellow.
It looked pretty yellow to me.
It had the same stickers as their other ones, and I think it might have been the photo. Because who has all white helicopters and one yellow? We'll see. I don't want to bet a whole meal, but
100% yellow.
I think I'm gonna write it down and ask him. You saw the guy's shirt. It was white. It was pressed. It said television on the back. They know style. I don't know.
Maybe he was wearing a yellow shirt.
Speaking of color. All right, well, we'll see what happens. It might have. I was just thinking that when I was looking at it. I'm like, that's strange. Why is it yellow? All right, today we are doing wire identification. So I do have a short story for you about identification. When I was a kid, we had a cat. We lived by a road. Cat gets out. And anyway, guy comes to the door, knocks on the door. And my mom was home, but the guy looked sketchy, so she only opens the door like 2/3 of the way. She's like, hello? And the guy's like, do you have a cat? Starts getting even sketchier, right? And I'm like, yeah. And he's like, well, I think I just hit it on the road. And my mom was like, this is weird. And she's like, well, what does it look like? And he goes, my mom goes, no, before you hit it. Alright, identification. So, proper identification is important. I'm getting old, I know, but those get funnier every time. Alright, we're gonna do some planning talk, we're gonna do some routing talk, we're gonna talk about wire security. I even tried to push Mr. Tanner if they use zip ties or not, and his answer was,
Yes.
I don't know, I'm not a mechanic, is actually what he said. In your book, pages 53 to 59 would be a great spot for you to read. We're going to hit quite a few places in AC 43 today. We're going to hit a little bit of the manual of Cessna's 172, 1997 and on, which is the S model, which is what they primarily fly in the flight school over there. Because this only counts if you don't have manufacturer data, right? Cessna was kind enough to give you page after nauseating page of electrical data on their aircraft. So we're learning generics. That's what we do in here. A lot of generics come out of AC 43. When you start talking wiring, especially power plant, but aircraft wiring, you're going to do what they say. So I say that, say a lot of the generics that we're teaching, right down to wire selection size. In reality, you're going to go to the wiring diagram and you're going to put the wire in that the manufacturer said to put in. But we're talking generic. So those are the pages you're going to want to go to. We're going to rifle through a fair amount of this stuff today. Page 50 says, I had the old book when I typed this, I might have moved up. It says there is no standard for wire identification. And I'm like, oh, that's helpful. Mostly what they mean there with that statement is there's not wire language. There's not, hey, I'm going to label this wire number 53. The other manufacturer is going to label it 1-4321B. They all got their own method for how they decide what number or what label is going to go on the wire. There are some standards on how we label wires, though, so we're going to cover that a bit today. AC 43 in 11.205 through 11.222, that's like 17 paragraphs, right? There's 17 paragraphs about wire identification. You think it's important? Yeah, apparently. So I would recommend reading that on your own. I put it big, I put it yellow, I highlighted it in red. Just when you get a chance, maybe in lab time, skim through. It'll be a review of what we talked about today. But just so you see it, you don't have to take it all from me. General things are within 3 inches of the end of each wire, you're going to want a label on there. And you go, well, what if it's only a 7-inch wire? Do I need to put 2 labels 1 inch apart from each other? We're like, okay, you know what? If the wire's less than 7 inches long, just put the label in the middle of the wire. They even get to specifics like that. AC43, I believe is where it says it, is it should be every 6 foot along the wire as well. So if you start in the cockpit and you got that wire going all the way up to the tail for the tail beacon, should be labeled every 6 foot as AC43. Most manufacturers are going to tell you every 15 inches. Here at SMAT, I want to see the label on these wires you're making at the end. I don't really care about the middle because we don't have the correct labeling equipment for it. But if you want to put it every 6 foot or 15 inches, I'm not opposed, but I'm just saying that I'm not going to mark you down for not having it every 15 inches on the wire because I don't have the tooling for it. But you're going to see that is actually where it's at. Figure is 488 in your book. Is anybody there? It's like this image. Somehow online, it made them all zeros. I think I'm giving my numbers. You guys have this image in your book, roughly figure 488? Yeah, so take a little glance at that and go, oh, I see there, 3 inches from the end. What are these ones in your book? 6 inches, so 6 inches apart. Feet. Yeah, inches would be pretty close, sorry. 6 feet apart. So anyway, it gives you that. They're generics. And one of the other ones, kind of obscure, I read today, was like, okay, if you got a zip tie or something like that, you can put it a little farther if you have to. So, like, say it came right out and I don't know what it had to do. It had to do a turn, it had to do something. They give you some grace, but the idea is each wire is getting labeled. I hesitate to go further because I think I got it. I think this is the one where I go. I've got so many great points in my head, I can't remember what slide they go on. This is cut out of Cessna's manual. I purposely cut the pages off to make you go look when you get a chance on your own. So this is out of the S model 172. So if you're ever working on an S model, Cessna 172, you must follow manufacturer's instructions, right? And there's even words in here like shall. This isn't should, this isn't probably, this isn't suggested. It says shall. Each wire shall be identified with legible characters at intervals not exceeding 15 inches. For like, oh man. So if you're doing a newer S model, you better label that accordingly. Does everybody in the industry do it according to the law? No. Don't look at too many SMAT aircraft because I wasn't teaching class when they went through. But that's shall, it's what's in there. If it's an STC, they're like, okay, I'm not going to make you label all the wires that came with your STC. Just slap them in. That's what this one is saying, right? That's kind of funny to me. They give you the ways that you can identify them. So that one's interesting because it doesn't leave a lot of room for coming up with your own creative way. Now, is anybody going to pull your license for doing a different one? Probably not, unless it was like a tape that fell off and went into a carburetor and stalled the engine and somebody died. Then they might, but if it's a industry recognized, you're probably going to be good. But they get hot embossing on a single wire. That's kind of cool. It's basically like wire stamping. You got a hot stamp with a number on it. And they have a whole section in AC43 and in the manual that says if you do that, they have how deep it's got to be, and because you know we're wrecking the insulation, so they're like super careful about that one. Actually, that's not hot embossing. Hot embossing is laser. So the one I just mentioned isn't listed for Cessna. Hot embossing on pressure-sensitive tape. Well, how do we keep the tape on there? That's the trick. The marking on vinyl sleeves. We're gonna cover that a little bit later today, but I had to look up, what's heat shrink made out of? Vinyl. I wasn't sure. I was like, is that heat shrink? Turns out, if you do a Google search, heat shrink's a form of vinyl. So vinyl tube. We had a cool printer. We still have a cool printer next door up in the attic. It's in the pile of stuff we're gonna throw out, but we gotta wait for old people to leave so they don't get upset with us. It's just how it goes. It's not Dean actually, it's Marv. He gave us a printer with a bunch of different cartridges. The problem is it's got the old telephone thing that you plug into the back that you gotta plug into your computer. And I don't have a computer that's got a telephone plug in it anymore. So we're not using the printer, but I went up there and I found this. One of them, it would print on, if you pull a little bit out and look at it, it's actually heat shrink tube. Very similar to this heat shrink tube. It's already nice and flat, which makes it easier to use your pen on, because this stuff's a little bit of a hassle. So I'm looking at this going, I think if you look inside there, I think that's like 15 foot maybe. I don't know. So you trim a little 3 inches off for smat use. I don't have a printer that's going to work, but you take your pen, you write on there, cut it off, put it on your wire, heat shrink the wire, and I do believe this one is from that. So we don't have to use the printer. Now, if you right away touch the ink with your fingers, it's going to rub off. These ones I did with our regular heat shrink tube, and I did them with a magic marker. The magic marker ones are still on here. You know, there's an old Chinese proverb that says, even the most faded paper is better than a good memory. The one I did with ink turned out better. So, your wires in here, it takes a little bit of work. I didn't want to make you label every wire for your project because it would have been a nightmare and it would have been a ton of heat shrink too. When you start working on an aircraft, when you get out into the field, especially if it's a Cessna S model, if you want to follow the law, you will be labeling them. Good airline shop will have a printer that, like, the wire goes in it and it just prints it right on the wire. It's pretty cool. We're not a good airline shop. So heat shrink's the best way to label your wire. I'm going to go with that. Questions on that? Good. Back to what we were saying. If you're working on an aircraft, if you're adding the STC, it probably is going to say in the STC what wire size or come with it. If you're not doing an STC, you're going to go find the wire that's in there. So this one goes from A plus to alternator. Well, that's going to be a big wire, isn't it? So that is DPB12. Should I sound smart? That's Delta Papa Bravo 1, 2. Doesn't that make me sound smart? You're going to want that label not in the middle of the wire, but you're going to want it within 3 inches of this side, within 3 inches of the other side, and then in every 6 footish, depending on what airplane you're in. That's the number you put on the wire. Make sense? Okay. Let's say, what size is that wire? PB12. There's a GA here for gauge. I can't read it. There's a 5 there. 005. 5 knot. Let's pick a different wire. Let's go with this one. PB. That's a ground wire. Let me give it a small wire. PB26. PB26. 185. Do you think it's a 185 gauge? No. 185. 185. What do you think that could mean?
18 gauge, maybe shielded.
Ah, bingo! This guy's thinking.
Is it S or is it 5?
It's an S. It's an S. But how do you tell? I mean, it's some handwritten. This is why you guys need good handwriting in case our computers go bad and you have to go back to this. Notice the dotted lines. That should have been your clue that more of you than just Leo should have caught. Those dotted lines. The dotted lines are the shielded part of the wire. So they'll give you a pretty good clue on the shielded one. they're not gonna leave you hanging with, oh, I hope he read that really close. So those are the numbers that should be on there, and shielded or not, and that's really how you're gonna decide what wire to put in an aircraft. The chart is just so the FAA has something to test you on. Okay. That one's not a lot more readable, is it? So this one says 2 pitot heat switch, and it's got a 1. It doesn't give me a wire number, does it? That's interesting. So probably on this wiring diagram, what I would have to do is head over to the other diagram and say, what number am I going to put on the wire? So some of these, because that doesn't give me a number, right? Some of these will say on here, and I wish I could read it better, but they'll say on that chart, unless otherwise stated, all wires are something or other gauge. Maybe it'll be on the next one. I think that was what I was trying to get across on this image, but it's not getting there. So I got a 14 gauge, 14 gauge, 18 gauge, 18 gauge. In the PA15, PA16, PA13. So it is listing these ones. But some of the wiring diagrams will say, unless otherwise stated, all wires are. So if you can't find the gauge to the wire you're on, look for a note like that. All right, what do we got here? We got a landing light, MLC1. I don't know if I have that as an option. That's interesting. Oh, I got a 1. Does that give me 1 right here? Oh, that's just telling me the switch. Huh.
The right one, like 4 or 5 of it each.
Oh, there you go. 14 gauge. Good eye. So 14's here, GA down here for gauge. Excellent. I went through this once. That one's 14 gauge. LC15. We got 15. Hard to read. 14 gauge. I go through a fuselage, and now I'm heading out to the light, and all of a sudden I go to tan and gray. They start telling me colors. Oh, tan. So that wire is wire number 10. Go figure. So if you're going to make a label, tan it is. 14 gauge. So anyway, you get the idea. Oh, there it is. Black 2. Is there a black 2 wire? 16 gauge. That's weird. We fed the thing with 14 gauge, but then we come out with a 16 to ground. Why would we switch gauges? 16 gauge would be higher resistance.
Oh, yeah, small wire.
It is a smaller, so why would we do a smaller wire? Less volts. Wires hopefully don't see volts in that sense because there's a voltage drop across it. So we're on the right path with voltage drop across it. What'd you say? How long do you think this wire is in real life? Feet, right? Goes all the way from the cockpit to the light. How long do you think that wire is in real life? Yeah, so we're not so worried about voltage drop across the little tiny wire. So they're like, you know what, we can get away with the next size up gauge. We'll go up to the next size. So anyway, that's borderline going to be considered a grounding strap or bonding strap, right? Depending on how the aircraft manufacturer looks at it. So, all right. Oh, this was just kind of a fun one. Does this switch look kind of... Oh, never mind. It's not as fun as I thought. Does it look strange to you? There's a little line that connects the two. So I know if you turn one on, the other one turns on. I guess they each go to their own light. So, interesting. I flick one switch on, it turns both lights on. So, what would we call that?
Double pole, single throw.
There we go. Double pole, single throw. Off doesn't count as a throw. So, off is, we don't count that. So, you can have it in the on position or the one we don't count. So, double pole, single throw. Oh, that wasn't too bad. We're moving along. We're going to go over these things. I'm supposed to grab my book and go to 455. If you want to go there with me. 455. insulation. Really, you could just read this, but I'm getting paid to teach you, so we gotta go through it. We wanna protect our wires from chafing or abrasion. What does chafing mean?
Rubbing down,
What's the difference between chafing and abrasion then?
shaping is also rubbing, abrasion's cut.
Okay, I'll go with that. I didn't know, so I was asking you guys. High temperature, obviously. We covered yesterday, we'll talk a little bit more today about some of our temperatures the wires are allowed to be in. There's different ratings on the shields, the insulation. Number 3, being used as handholds or support for personal belongings and equipment. It's funny that they have to put that in there. But basically they're saying, you know what, just don't run a wire where there's people, because people are dumb. And they'll grab onto it, or they'll hang their coat on it, or, so, that's the way of putting, just don't put wires by people. That's essentially what they're saying. Damage by personnel moving within the aircraft, back to basically the same reason. Damage from cargo stowage or shifting. Yep. Damage from battery acid, fumes, spray, or spillage. That one, each manufacturer's gonna be a little bit more specific. Your book talks a little bit about it, but we're not gonna wanna put our batteries above a wire. Maybe I should phrase it the other way around. We're not gonna wanna put our wires underneath the battery. So you can read about that, somewhere in there it talks about it, but I probably wouldn't, because that's pretty much what we covered. We don't want our battery acid to get on, and then the fumes they're being careful with as well. Alright. I said I'm leaving labeling, but I got this comment about, oh, isn't that so nice how that looks? Nice label. So you can label a whole bundle as well. There's actually, if you're looking for, can I use cable ties, zip ties, you'll get off in the woods in AC 43 in a section that says you can use cable ties for, one of them is securing labeling to wire bundles. It's like, oh, okay, good to know. I can use a cable tie for securing my labeling. It talks more about cables for that than it does anything else in AC 43. But you can label a bundle. I didn't know where to put it in the slideshow. Sometimes we have where we twist the wires so that their magnetic fields basically fight with each other and don't interrupt stuff like our compasses or sensitive equipment. So a twisted pair or twisted wire, that's what they're talking about. There's one weird question in prepware, and maybe once or twice in your life you'll have to deal with it. But they deal with some twisted wires every once in a while. 3-phase power distribution. If you start working on like airliners, it'll be more of a thing. They'll twist them up so that the frequency doesn't radiate into all your radios and stuff. Supposedly twist them up. Basically it breaks up the signal. So anyway, twisted pairs, kind of weird. Okay, splices. They absolutely want you to know that if you put splices in, they should be staggered. They also want you to know you shouldn't put splices in. So how do we teach you both things without sounding like we don't know what we're talking about? I don't know if you can. So if you put splices in, stagger them. We wouldn't want to have a splice, 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 and have this big thing. They want you to know that. You'll get it on a written, absolutely guaranteed. What you might not get is that they really don't want you to put splices in. But just because they don't want you to put splices in doesn't mean you're not allowed. That's one of those shall, should, would, could situations. And we're going to read about it when we get into the assessment manual a little bit later. Slack. You slackers. Half-inch maximum with normal hand pressures. This are people walking through the cabin hand pressure? No, we're not letting those guys get anywhere near our wires. This is you guys when you put it in. So what they're not saying is, when you run your wires, that you should see a half-inch droop in between all the supports. That's not what they're saying. What they're saying is, It should pretty much be tight, not guitar string taut, but pretty much tight. And if you go like this, yeah, you should get about a ½ inch down. You might think, while you're talking about this a lot, why do I care so much? I was just flying a tailwheel illustrated the other day, and we're rumbling down the grass, and I'm looking at the back of the airplane, and the whole thing's going all over the place. And I'm like, I am glad I'm not doing the 100-hour inspection looking for cracks on this. And you can hear the cables slapping, and you can hear the wires bouncing all over the place in the back of the aircraft. So we want to have them tight, but we don't want it so loose that when we're hitting all those bumps, the thing's bouncing around and slapping stuff and possibly grating. Chafing. We don't want it chafing, yeah. I didn't used to know what chafing was until I got a little older. They actually say on page 4, I wrote 55, but I think it's later for you guys. They say slack is a good thing, so you can tell your instructors, the book says slacking's a good thing. Slack's a good thing. For reasons, they give you some reasons. They say easy maintenance. If you have no slack and you have to put a new terminal on the end ever, good luck. So a little bit of slack's good for some maintenance. It won't have strain like a guitar string. They can move around. If you have to move it to work on something that's in the general vicinity, like fuel lines that are under it, because we don't want the fuel to drip down onto it, or a battery that's under it, again, because we don't want the battery acid to drip down onto it. But yeah, generally speaking, they want it secured. Okay, I was told to ask you guys to go read 11-96 in AC 4313. Somebody needs to read part O. O for Oscar, just a little O. So just Oscar, not big Oscar, little Oscar. 11-96. I could have done it. That's paragraph. Paragraph 1196, Oscar. And if you're going there, you'll notice below Oscar,
Do not use tape, eye strap, or cord for primary support.
I need those last two words a little louder.
For primary support.
Alright, do not use tape, cable ties, or what was the other one?
Cord.
Cord for primary support, like lacing cord. So even lacing cord, we can't use for our primary support. It's a pretty big deal. We're gonna come back to that later. I feel like I'm on the wrong page for that. But, oh, I know why I did it on this one, just to hammer it in. Notice, primary support, we're just trying to make it look neat. Okay? So, zip tie here, I'm fine with that. I don't have a problem with that. Zip tie, tying it to the structure so our wires don't fall down and hit something, not fine with that. So, that's kinda how the FAA is looking at zip ties. Alright, bend radius we covered in airframe, 10 times bundle diameter. Yeah, okay, we can go down to 3x in certain instances if it's supported on both sides right across from the terminal. But if we're going to talk about that and open that can of worms, you can't go that small with coax. Coax is 10x as well, but they'll give you down to 6x on the coax cable, right? When you replace the wires on the aircraft, me and Bean don't want to hear, it was like that when I found it. That doesn't fly in the aviation world. Now, if you're replacing a wire and all the other ones are garbage, you could say, they were like that, but even that's not good practice. So maybe clean up a couple of them, leave things better than you found it. But routing should be neat and tidy. They like to say parallel or perpendicular to stringers and supports. The idea is you're running, you know, it looks nice. When I used to be heating and cooling, you'd be in the corner of the basement over here with the gas meter, and the furnace was in the corner of the basement over there. You're going, it's cheaper if I just go exception is coax. It's not that this is more important than this. If anything, I should have put it the other way around, but I wanted to make sure that you heard the exception. The exception is coax cable. We don't run that in a bunch of bends. We want that as short as possible, and in reality, we don't want it by other wires. So we're like, well, just make that one look ugly. Did I say that out loud? That's what we do with coax cable. All right, red wire. This is grandpa. Anybody see anything wrong with the red wire? Ooh, that one's not chafing, is it? That would be abrasion. That is definitely abrasion. So, this was from one of you guys when you were doing instrument class. I went up under there to check on the instruments, and I moved the control yoke, and the control yoke swung back and basically grinds the wire right into the radio. And I'm like, ooh, that's probably not good, because that's a pretty good size amp draw wire. It's red, which not always, but probably hot. It's probably a hot wire. And it's you're going to grind it right into the bottom of the radio. So I can just picture it, right? You're coming in for a beautiful landing, you're flaring, and it shorts out, and we got a fire in the cockpit. You know, wouldn't it be good? Wouldn't it be good? So, especially on the wires, and that's why I gave you 3 days and 6 hours of lab time to replace a wire in an aircraft that hopefully will go through a firewall that you get approved, is to get back in there and realize this might not be as easy as I thought. We have a handful of these in the Molex connector thing, I think, right? If the wire you're replacing goes through a bundle that's all tied up, you don't have to cut them all. You can just stick that through and run it, yeah? So, a little reminder on that. But we do want the wire that you replace secured properly according to whatever that paragraph was, section O for Oscar. Not using tape, cable ties, or lacing is primary support. Gets a little funny when you're behind a control panel, I will admit. That one's a little weird. I don't have a good answer for that. Also, did you notice this? That's all. That doesn't look, that's not factory. The radio wasn't found very secure. I'm not saying that was you guys. I'm just saying at some point in the last 20 years, there's been a lot of SMAS students in there. So yeah, secure some wires. Chafing, abrasion. That was Dean's book. He even thought it was important. Firewall. These little grommet things. It is a firewall, so we're trying to keep fire from going from one side to the other. But there's really 2 functions on those. Actually, you know what? This is a good spot for a break because they're all going to be clamped. So let's take a break. You guys want 10 minutes? 9 minutes? Is that too long? All right. Come back at 5 after. I need a chocolate. Think they'll be gone?
If Dave gets in there before you, yeah.
Ah, dang, that would have taken.
Remove.
ones are by all the other ones in the parts room, in there, if you walk in the parts room right under the electrical, right? And they're mixed in with all the other colors. I'm gonna leave these out. This is probably pretty close to enough for all the wires you guys are gonna do, cause you're only using a little section on the end, right? So we gotta leave these somewhere, and we gotta leave these somewhere, and, I don't know where to put them. Suggestions? Should I just leave them all together by the, on a table? Say what? Tell you what I'll do, these will be where they go. You know where the printer normally sits next to the torque wrench?
Yeah.
I'll put this there, cause this isn't really, I don't wanna use this for standard heat shrink. So, if you wanna use this style, which I recommend until it's gone, I'll put this by the torque wrenches, so you can just look for that. Okay. Where all the random hardware that's not that random, Dean works pretty hard to keep that organized actually, there's a tray totally full of various size clamps. So I brought one in because I stripped it off Corbin's project, I think it was, when I was cannibalizing it. But there's a whole box of clamps, so when you're securing wires, which we're gonna be talking about now, that's where a ton of those clamps are in various sizes. Alright, going through the firewall, that's typically made out of what?
Titanium.
Or stainless steel.
Titanium. Stainless steel used to be the answer, maybe we upgraded it to titanium. We don't want fire going through there. So often there's a material in there sandwiched in between these two halves. So this device, depending on the aircraft, does two things. One is it holds the wires from abrasion, so they don't get roughed up. But number two is that's supposed to stop the fire from coming in to where you are. In SMAT, in this setting, if you can find some putty to put in there, cool. I don't know that we have any. Reuse what's on there if it's the kind of black nasty stuff. But if you leave it open, I'm not real worried about it, because if you were working on the aircraft over in the LLC, you're gonna get out the actual adhesive that's made for it. It's really sticky, it doesn't come off, and it's a hassle for the next guy to pull a wire through. We don't wanna do that to you guys. So don't worry about sealing the ones that go through a firewall, but I'm talking about it longer than you wanna hear about it, just so we get the point across. Normally you would, and I have some slides up a little bit later that talk about various materials for that as well. Remember, our insulation is just thick enough to do the job, so if you get chafing on the insulation, it is bad insulation. So when you're doing inspections on the 414, now I mean if it's just a tiny little bit, there's within reason, right? But if we got cuts, especially if the insulation is cut, the insulation is bad. That means the wire is bad. There is a section in AC 43 that talks about how you can possibly deal with that. I didn't read it real close. Maybe I will someday. If your wire goes within that 1/4 inch of a hole, we need to have a grommet on there, approved grommet. Ooh, fancy. They also have a prepware question. They gotta ask you something, and they'll say, "How do I get that grommet in there?" And they're like, "Well, if you cut it on a 45-degree angle and then put it in there, it'll fit in nice." So instead of cutting that grommet just straight across, where it would tend to want to work its way loose and fall out, there's a prepware question somewhere that says if you cut it on a 45-degree angle, it helps hold itself in. Kind of obscure, but interesting to know. But that's only if you're within a 1/4 inch of the edge, generally speaking. This one's got a nice clamp. I don't know how much they blew that up. That doesn't look like a 1/4 inch to me. That looks like I got a 1/2 inch. I probably don't need a grommet on that one. But if you were within that 1/2 inch, grommet is needed or required. Alright, I was searching the internet, trying to figure out how to use this stuff. Was kind of, oh, Vinny.
Question for
I'm guessing they meant a 1/4 inch. I don't know. I don't know what else to tell you. I've never, cause that's,
No, it was
quarter of
the
the wire
conduit.
diameter is weird.
Was it? It was for the conduit.
Yeah.
Oh, might be extra space inside. How full can you jam a conduit full? Maybe that's what they mean.
It's like how much space can be between the conduit and the wire bundle instead of 20%?
Is that a minimum or maximum?
So admittedly, I'm not 100% sure what you're talking about, but if that's a conduit, would we want to totally fill that conduit with wire? What they're probably saying is, let's only put a bundle that leaves 25% left for room. I think that's where that one is going, and that would make sense where you could get it confused with something like this, right? So have 25%, yeah, because that doesn't make sense for that. Good question, though. Glad you asked. Okay, back to that one. This is the material I found that Cessna said, and I think it's the 172S model. I just happened to grab that one. I'm going to hang out on 172S model for a while today, just because I want to read all the manuals, and it gives you a flavor of what's going on. But, shoot, what's the first letter there? Something 2100 primerless firewall sealant. In practice, high temperature silicone, what do they call it? HT, is it HTS? Sometimes they'll put another letter in there. Can't think of it. Anyway, red, it's typically red. It's not always red. Sometimes they don't put the red in, but there's a red silicone that can take high temperatures. A lot of times, they'll get sealed with a high temperature silicone. If you find the stuff that's actually in the manual, it might look like that. I don't know how to use that can. I think it comes with a little end on it for squirting. But there is a proper material for sealing off your wires going through a firewall. Otherwise, like I said, there's different putties and stuff like that. Dapco, that's what it is. 2100 adhesive. Fun stuff. Oh, yeah. That was in 2007, Cessna listed that. So we've had a few years since then, but they officially said, well, go ahead and use that stuff. So some of our areas are going to be called for our wires to be protected with high temperature sleeves. Is that so that the wire heating up doesn't damage anything? No, the other way around, right? Maybe we're running it on top of an engine or something like that, and we don't want to damage the wire with the heat. In that situation, and I think we covered it in airframe a little bit, we got to be kind of careful. We're trying to keep heat from coming in, but we make heat with our wires, right? So we got to be a little bit careful with this stuff. You're not going to see it run for real long lengths typically because the heat would get stuck in our wire and my wire could overheat or get hot. But that's what they're talking, high temperature sleeves. A lot of times you'll see it if wires are near exhaust pipes to keep the heat from the exhaust pipe from getting on the wire. Yeah.
Copper's pretty good at conducting heat. How much problem is it actually with the wire though?
So because our wires where these are at are usually only a foot or two long, it's like, yeah, we're probably fine. And that's why you probably don't see it that much. Maybe another way to phrase that would be anytime we're doing something like that in that area, hopefully you're checking the manual. It'll probably tell you where the wire goes and or they're going to give you a wire size, wire number. You're not going to be picking wire size anyway. But I'm throwing that out there just so you're aware of it. If there's a prep work question or DME starts asking questions about high temperature sleeves that you're like, okay, I'm protecting the wire, but wires do give off a little bit of heat. So probably not going to see big bundles of wire running through the aircraft. It's more kind of the point I'm making.
Does that go over
Over the
the
wire.
wire itself?
Yep.
It's not like it's a special type of wire.
Nope, over the wire. Yep. It's kind of like a heat conduit. All right, what's interesting on these is anytime you have a conduit, and I go back to, you think metal, they want somewhere for the water to come out of it. So any spot where water could pool, we're gonna put a hole in it so the water can drip out. Couple other things, never under battery. I thought this one was fun. Avoid the lowest 4 inches. I was like, what's bottom mean? Fuselage protect from fluids. That must be like jets. I actually put a tape measure in the 206 because I'm like, that's weird. And I got some wires down pretty close to 4 inches, but there's only like 3 inches down there. Also, I see stains from where water in our float plane had got up and dirt and crap. So just be aware of that. We don't want wires run in the bottom where water could pool. Where's drain hole? And sleeves. Talked about that. Wires go above fuel lines, not below. That image is interesting. They're pretty specific about we're not going to put a clamp on a fuel line to support our wire. And then they show us some pictures with clamps on fuel lines. And so technically, this is not supporting the wire, okay? This is separating the wire. It's separating the wire from the fuel line. They're okay with that. They're okay with separating, but they're not okay with supporting, just the FYI, right? The other one that I thought was interesting is probably what Corbin's gonna say. Yeah?
I don't know what you're thinking.
That clamp shouldn't be like that. It's upside down. Didn't we cover that in airframe? We don't want the wires to fall down and get pinched in there. Somebody can get a job with the FAA, just write manuals.
So if that's a separation of support, does that mean you still have to have that proper support, the correct spacing of support?
That's a great question.
Like if that's between,
Yeah, how many inches? I don't know. I don't know if I've ever seen one do that, just because the manufacturers usually are pretty good at not running them by each other in the first place. But I think the point they're trying to get across is we don't want the wires rubbing through our fuel lines, oxygen lines. So by all means, we won't say you're supporting it. Just put a separation on it. 1/2 inch of a combustible line. How far was it from the hole before you grommet it? 1/4 inch. They upped it to 1/2 inch from a combustible line. We don't want the wire running through the line, causing a leak, and now we got a spark and a fire. That would not be good. I couldn't find a good picture trying to get this across. It's my pet peeve on cable ties, plastic cable ties. Okay, this is off Google just to tell you what swamp areas are, because even in AC 43, it talks about if you have any wires in swamp areas, make sure that they're special wire. It might be special insulation, it might be a special conduit. You wire special wires in swamp areas. And I'm like, there's a lot of acronyms. I have no idea what swamp is. So I pulled it off Google. Severe wind and moisture prone is what swamp is. Severe wind and moisture prone. Now, I think that the aircraft manufacturer will actually label where those areas are on the aircraft, is how it reads. They'll be like, these are the swamp areas. So there's less up to your discretion on, is this a swamp area or not? If you're in question and you're running a new wire somewhere the aircraft never had a wire, number one, you better stop and think, why am I doing this in the first place? But number two, just be safe. I was looking at the 414, I think it was. You look at the alternator sticking through the cowls, where it breathes in all the air to cool the engine. So, I don't know, who flies 414s? How fast do you fly those things? What's the yellow line, 150? 150 knots?
No, shot, gotta be like 180.
180? Yeah, man, they're fast, right? You go look at that aircraft out there, and it's got wires hanging, and it's right behind the prop, which is probably, can't be better. And then there's like a cable tie, right? I'm like, geez, oh beats.
We're talking about
For the alternator.
Oh.
Yeah, it's actually alternator wiring. It's terrible. I don't know how they're supposed to be, but I can't imagine. The question is that really a swamp area? Severe wind? I don't know. So, I was thinking we could replace some of those wires. If you get looking really close, they've got a capacitor zip tied onto it, which isn't airworthy, but I don't know where you'd put it. So, if you wanted to clean up the alternators on the 414, some more of the work might be planning where'd that wire go. Maybe we can move the capacitor or figure out how to do it, or find a book and figure out how it's supposed to be on the 414, but that might be some good wires to do on the 414, because you just look at it and you're like, that can't be right. That's gotta be smatitized. But that's swamp areas is no touches on zip ties. No zip ties. Oh, AC 43, 1158. So I gotta go to 1158. There, 11. I got a lot of highlighting when I get there in this section. Close, close. Oh, too far. Oh. 41. Is it not a 58? 151. Why didn't you guys correct me earlier? You're gonna leave. There is no 1158. 11158. Okay. 11158. Under lacing and ties says, ties, lacing, and straps are used to secure wire groups or bundles to provide ease of maintenance, inspection, and installation. Braided lacing, tape per mil, blah, 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 is suitable for lacing and tying wires. In lieu of applying ties, if you're lazy and don't like them, straps meeting specification MS 17821 or MS 17822 may be used in areas where the temperature does not exceed 120 Celsius, which is 250 degrees Fahrenheit, not that hot. So if I switch that back, I went and looked it up, and it's a specific plastic. So if you have a cable tie that's made out of the correct plastic, AC 43 says you might be able to use it. If you have a cable tie and you don't know if it's made out of the specific plastic, no good. So, wanted to point that out. It very much spells out what plastics they're made out of. The guy from Mission, when I was asking him if they can use cable ties, he was like, I think there's something about you can only use the ones that have steel in them. So, I believe in Europe and international, there's something about the little clicker that locks it. At one point, they had to be metal ones, and they've changed the stuff around because the whole industry is trying to figure out what cable ties we're allowed to use and what cable ties we're not allowed to use. But right on AC 43, they have the correct plastic. Straps may not be used in areas of swamp. They may not be used in high vibration areas. Pretty much engine compartment. Pretty much. Question?
What do you mean by strap?
Where does it say strap?
Straps may not be.
Yeah, that's zip ties and straps. Zip ties would fall under that. Straps and cables.
Well, what's the difference between a tie and a strap then?
A tie is lacing. You tie it.
Well, then what's the difference between ties and lacing?
Oh, lacing is when you use the tie and then go down and do another one. It's the
Oh.
run. Yeah, lacing is a long. A tie is
Same material, different.
Yeah. A tie is one knot. Lacing is when you. I lace my shoes if I go through a bunch of eyelets. I tie a knot. That's a bad example. All right, here's the big part I want to get to. The strap. You gotta start over here. They may not be used in high vibration areas where failure of the strap would permit wiring to move against parts, which could damage the insulation and foul mechanical linkages or other moving mechanical parts. They also may not be used where they could be exposed to UV light unless the straps are resistant to such exposure. So some cable ties, plastic ones are black, they're UV resistant. They can be used out in the sunlight if they're allowed to be out there. There's helicopter dudes that use them on the rotors, I think, because they got easier to do than safety wire. I think the Blackhawks, they have a couple specific areas that use cable ties out there, because they're cutting them off constantly to keep the sand out of stuff. So, all that is back to, they're not supposed to be primary support. We read that in part O, right? So it's to make stuff look neat, but if that cable tie were to fail, it shouldn't let the wire fall down and hit on anything else. So primary support keeps it up nice. The cable tie is just, it's making it look neat and tidy.
For our clearances going through a hole in figure 11-14, it says minimum of 3/8.
That's interesting.
The picture for?
Page
Where
four?
where'd we get the quarter inch?
Where do we get the quarter from the textbook?
Oh,
Page 1160.
yeah.
Oh,
Right on that page.
where?
Page 11, 6.
It shows it, you got it right up on your screen. It's the illustration.
Yeah. I was looking where we got the quarter from. Is the quarter-inch one if it's less than?
That's less than 3/8 feet.
Oh.
I wonder if they considered a quarter is less and we're only going in eighths, and they're like, if you get down to a quarter, you need to ground it. We're splitting hairs. Good question though. Your textbook, I took that image from, is the one that had the quarter. I think. Did you find the textbook?
I didn't know that.
Yeah. That one does say 3/8 though. Now you got me. We'll check on break. Pretty sure I grabbed the one image out of the textbook. Yeah, textbook. So the question is, where did the textbook get the info from? Good question. Huh. All right. Oops, sorry. One thing, I know you guys didn't get hammered with this as much as my class did, but motor mounts. Zip ties can be a pretty big no-no on those. I believe the idea behind it is if you have an actual clamp, especially with rubber on it, it's going to stay pretty tight and not allow any dirt underneath. Zip ties on the inside, they have all those like saw teeth, right? Which is a great spot to catch dirt and whatnot. It can get under there. And especially in a high vibration environment, what can happen under that zip tie is you get a little dirt under there. It's actually not the zip tie that wears through the motor mount, but the dirt that gets under the zip tie and then sits there and vibrate, and it can actually wear into your motor mount. So motor mounts are one of those things, you don't want to replace your engine mounts because you zip tied it. That's one place to be super careful, and it's best to use a clamp with a rubber. Apparently those don't have the issue of getting dirt under them and wearing through. I think it's because you're clamping a little tighter. When we were in class, they actually had some motor mounts they displayed and showed where the zip ties had wore through, and they had to change the motor mount out because some guy was using zip ties. So anyway, it's hard to see in here. Cable ties, securing stuff together, we're like, yeah, okay. Best is this, right? Primary support. That's just to try to make stuff look neat. But these were some actual aircraft. I just took some pictures to go, hey, what's out there? This one, it's hard to see why I took the picture. Cable tie. I think it's up here. The picture didn't show up well. You got like a motor mount with a clamp and then a bolt and then another clamp to the wire. That's the best way to do it. I'm sorry that didn't come through, but I'll draw it. There's your clamp around the motor mount, and then they have connected to it another clamp there with the wire running through it. So that's the best way to secure a wire in the vicinity of a motor mount. Because you pretty much aren't going to get away with engine compartment zip ties for primary support. Because if I see it, I'll cut the zip tie and then we'll see what the wire rubs on. So like this. Yep, that wouldn't fly. That's what we want. Something to that effect. expensive zip ties, pretty cool. You could get away with putting those one on engine mounts, so especially the experimental people, which we don't talk much about in here. But they like those, they'll buy those ones because they like to secure stuff to the motor mounts because apparently they don't know how to use clamps, the real ones. And they're fast and easy. So it's a zip tie with a little bit of rubber on there, and then the rubber is cushion enough that I guess you can't get dirt under it. It doesn't move around. So pretty expensive. You can also undo them. You just put your thumb in there and you can undo it. There's a couple brands that make them that are actually aviation like grade or rated. So if you're the kind of person that starts doing a lot of wiring and you just gotta use your cable ties, buy the good ones and charge the customer for them. Over here, I know what I'm supposed to be looking for. It's hard to see it. So they used a cable tie. You don't see them anymore because they're hard to work with, but they used to make a plastic like lacing. And you'd basically you're lacing with plastic. It's really interesting. That's actually where the name cable tie originally came from, is it was just a plastic cable that you would tie, and then we upgraded to zip ties, which is why I always say zip tie instead of cable tie, which is what the book says. That word cable tie comes back from where you used to tie it. There's a plastic cable. I like zip because, zip is how it sounds. Zip. So you may run across true cable ties. I'm going to draw a couple images. Let's say we have a motor mount or anything and it's round like that, and we got a wire that we want to secure to it out here. Back to, we really don't want to cable tie that right to it because we could get some abrasion, we could ruin the insulation, we don't want it bouncing around. So we could go with option A, put a clamp around here. It's going to be a funny shaped clamp, isn't it? Tell you what, we'll go all the way over, because that's how the clamp would look. And then another clamp, and we could put the wire way out there. That would work. That's a really good way to do it. What they did and what you'll find in areas is if you take a cable tie type thing, I don't like these on motor mounts, but other places it works good. Wrap it around and then stick the ends out, and you take a piece of rubber tubing. Put a piece of rubber tubing there, and then you put your wire out here, and your cable tie goes around the end of that wire. I'm not sure if I'm drawing that right. When you cinch that baby down, what it'll do is it'll hold the wire out away from whatever object that is. That's a really neat way to secure, whether it's wires that you want to be spaced apart from each other. Maybe you got a wire that you need a space. What was our distance from a fuel line? Half inch. So you just need a half-inch long rubber tube, and you can use this method. It'll hold it a half-inch out. It keeps everything separated, and it's just a better way to run a wire instead of tying it directly to a round structure or piece of member. So I had a couple pictures. Some of the other ones might show up. The cable tie one had a similar in that you had a round piece and a wire. They came around with it, went around their wire, and then wrapped it around and tied a knot there. Kind of weird, but it just keeps stuff separated and it can make it look neat and tidy. Easier to do with a zip tie and a little piece of rubber. There we go. And there's another image of it that shows it really well. Pretty cool, huh? That way you're not cable tying it right to something. Now, I'm showing you a ton of pictures that got cable ties on engine mounts because it's SMAT and that's where my camera is. If I'm worried about dirt getting under my zip tie and wearing through my motor mount, what are some solutions that we could do? Anyway, creative solutions.
Use a clamp.
Use a clamp, that's the official way.
Rubber lining tape.
Yeah, buying zip ties, how about we just use a little bit of electrical tape? And now when my cable tie goes around, if dirt gets under there, I'm not so worried about it. Maybe the dirt runs into my electrical tape, but not as big of a deal. So if you must connect to an engine mount, putting a little bit of rubber tape under there, a little electrical tape, just to keep it from clamping.
Would your electrical tape don't trap moisture against the swamp, or?
Shouldn't be moisture in that situation, 'cause it's gonna be dry when you put it on. So,
Electrical tape doesn't hold up very well with water. So if it gets water exposed to it, you can trap it under it.
so clamps are still the best. But, yeah, a clamp's gonna be the same thing though, it's gonna, that's back to best case scenario. I think I got some pictures coming up. Best case scenario, you stay away from the engine mount. You put a clamp on a bolt on the head, you put a clamp on the bolt. Most of the time, you put a clamp on the baffling. You haven't had baffling class yet, and most of these engines don't have baffling, so it's hard to explain. But on a real engine, you're gonna have all kinds of aluminum baffling so that the airflow goes through the engine correct. So normally running wires is much easier than it is here, because there's all kinds of baffling and bolts and stuff holding the baffling on, and you just mount your clamps to that. Here it gets a little bit funny. So anyway, there's one with a tube. Here's one with the double zip tie, but it holds it away from the pipe. That is much, much better than if they would have just clamped it right to that pipe. You're not gonna get near the chance of having an abrasion that way. Oh, I was showing, this is actually, you can't quite see. You can see the knot, that's an actual cable tie. Alright, that's back to, here's a piece of baffling on the front of the aircraft. This is the best way. You use a clamp, having to put under a screw where the baffling is. I don't necessarily like them under valve covers, but you'll see a lot of them under those valve cover bolts, just because they're convenient places. Yeah, Corbin.
One of those valves with a bolt for your place, like one of the studs that has a nut on it.
That'd be handy. You should invent that. Make a lot of money.
It's already a thing.
It's a thing already? I like that. Alright, we talked about, remember that one image that we were separating the electrical wires from the fuel line, and I said it shouldn't be that way? It's because they had it this way. And we talked about it in airframe, but if it's here, and you got a little wire in here, it's a bunch of them, but it can fall down and get pinched in between those two. So we don't want to mount them so that the wire can get pinched in between. That's why those two are no-nos, and that's why that one's a no-no. This one's a little bit weird. It's hard to tell why it's a no-no. The closest I can figure is they would have rather have it up on top.
Isn't it because they see like the weight of the wires and it wants the bolt clamp on?
Exactly. So picture the bolt is right here. If I pulled really hard on this with my wire, it's going to try to pull my bolt and everything out. And that's why I say that one's a little bit weird. They would have preferred it to sit on top, and that way the weight of the wire just puts it into the support. But we're splitting hairs on that one. I just wanted to talk about it because that's like, what, really? All right.
Would that would be just as likely to get your wires pitched?
In this spot? Well, it's in the top, not the bottom.
I mean, when you put it flat on top.
What they're worried about is gravity working overtime with the vibrations and gravity. On these ones, the wire will work themselves out of getting pinched with gravity and vibration. On these ones, they'll work their way into getting pinched with gravity and vibration. Yep. So it's interesting, this one, the reason they give you 45 max is exactly what David said. It's like, well, we're like worried about the clamp pulling off. I'm like, really? But hey, I guess if you're doing 9 Gs, maybe those wires are heavy. That's what they're going for that. Alright, let me pause this a sec. I gotta see. Nah, we'll keep going, we'll rip through it. Alright, this is just thrown out for that review. If you don't remember how to do it. Lacing, when you're doing multiples, a tie is just one. I actually like ties better than lacing, because if you do lacing and stuff moves, it doesn't take that long to do a tie. Just do 4 ties.
Because you can use them
my opinion, ties are superior, they just take like 10 seconds longer. But you might get lacing on O's and B's, so.
So they say, if they say lacing.
If they say lacing's what
Several.
they want, yeah.
How you do that again?
Look at the picture, go practice.
Ain't there like a double?
There is, yeah, that one's double on the end.
I don't remember, but.
What I thought was interesting on this one was, if you got really big wire, number 2 or larger, they say to cut the insulation off with a knife. You get that big, you'll probably nick wires, it gets hard to get the insulation off, so you actually use a knife and carefully, usually what you're gonna do on that, if there's your insulation, and your wire's on the inside, normally what you do if you're doing it with a knife is you're gonna do a cut so that it kind of opens up, and then you carefully take your knife and cut around the outside. So large wires, that's pretty common even in the electrician world, is don't try to strip them with the wire strippers. Basically, you're so much force cutting through the insulation, you'll never realize you're nicking the copper as you go. Speaking of nicked copper, that is bad. That is not allowed. We gotta be really careful that we don't nick it. In your book, it'll talk about how many wires can be broken off. They actually give you a limit. We talked about it in airframe, I don't remember the number right now. But you can go back to that. Basically, if you break one wire, you better go double check. Am I allowed to have a broken wire? I don't remember if I'm allowed to have a broken wire. So go find it in the airframe manual, or AC-43, or just cut it again and make sure you don't have a nicked wire. Splices. It's an interesting area. Dean loves soldering, because, you know, the idea is if you solder it, they can't pull apart. That's one camp. Makes logical sense. Case doesn't like soldering, because I've found too many connections, not necessarily airframe, but broken, because when you solder them, you get the wire hot, and hot means brittle, and it's going to be susceptible to breaking. The idea is on a solderless, where you're crimping it, the stress of, if you have vibrations and stuff, it's supposedly spread out over a longer distance, where when you solder it, pretty much that first point coming out of the solder, you had it hot, and that's where it'll break off. So, depending on who you are, what the book says, there's ways to solder, there's solderless, there's fancy ones that they're like, got solder inside and they heat shrink, but you're not really supposed to splice. Anyway. Review, should be a ring. And you guys already did the ratcheting crimpers. They like that word emergency, right? Emergency splice. This isn't the leave it forever, this is until you replace the wire. As Red Green would say, this is only temporary, unless it works. Or it's my own airplane, and I don't want to pay somebody to put any wire in. But you're mechanics, so you're going to put new wires in. All right. Page 1134 talks about derating for bundles. I've done wire sizing a bunch with you already. The old chart would do the bundle, not bundle. The new chart does not. If you really get reading it, technically wire sizing, you're just going to go with the manual, but technically it's going to be use the chart, use the derate bundle, check for circuit breakers, circuit breaker size. So this is pulled right out of AC-43, and the idea behind it is if I have 10 wires in a bundle, and if I'm loaded at 100% means all of my wires are using power all of the time. So I got 10 wires that are all using power all the time. Wow, that number's hard to read. 1, 3, 4. It's about 45%. So I would take basically my amp reading, and I'd say I can only run 45% of the amp draw through it. If I go up to this line and it says, well, you know what, only 20% of the wires in that bundle are using power all the time, then I'm way up at, well, I'm okay with 75% of the amp draw in there. So, when you use this chart in real life, when's that gonna happen? Never. But just so you know, when you use this chart in real life, you would use the chart. The new one doesn't have the curves, which means you use this chart, then you go to this chart if it's in a bundle. So, FYI, fat finger. Chart, then circuit breaker. And I put that over on the right, just to be super, super clear. D-rating. Because in a bundle, they're not gonna give off heat as well as single and 3-air. So if you read through AC43 really, really close, it'll say those charts are for a wire and 3-air. And that changed from the old AC43 from the old chart. All right, this is from Cessna. You already read it. I don't know why it's there. This is from Cessna. Gives you the manual number. I think I'll just put it in there so it gets you going in the general area. This is a really good read. Basically, this page through about 5 more, it reads almost identical, to AC4313. Slight differences. So good little educational read. That's one of the things on the list I put is if you get a chance in lab where you're caught up or ahead, I'd highly recommend giving this a read. If you like it, go read another one. I don't know, 206 or something. But it talks about the general rules for wiring, avoid twists, kinks, not support on plumbing lines. The next couple pages are ways that they get a little bit more fun, but it starts to give you some of the spacing even between them. But that's the manual number. I think this was a couple pages later. General instructions. Generally, replace a broken, frayed, cracked, damaged wire with a new wire. It doesn't say splice it where it was broken, frayed, or cracked. It says replace the whole wire. And you replace it with the size that the manual says. Okay, good. I don't have to use the wire chart, right?
For point D,
What?
except for then they come with point D. Splicing is not recommended.
You're jumping ahead of me. Yeah, I know. It's terrible. Do not splice. Unless the integrity would not be affected. It's funny how they put it in bold, but as long, and then it's like, okay, fine. It's not recommended. However, in some cases, it may be. Who gets to decide if it's necessary? That's the real question, because that's a slippery slope. Now every time I see a wire, it's necessary. It's necessary for me to get to lunch on time. I'll tell you what's necessary.
That's right.
Right? So,
Where are we going?
and it goes to say stagger them. So it's not just this one time with the one wire. They're basically repeating AC43. Not very clear. Here's AC43, and there should be not more than one splice in any one wire segment between any two connectors. So basically, I got a connector in the tail, I got a connector in the cockpit. That's one wire. I should only have one splice in between. That's AC43. Some manuals, and that's what I thought this one said somewhere, and I just didn't find it. Some manuals will give you up to 3. But I'm reading AC43, copied it right out of there. Highlight, clip, says 1. Huh. So, I don't know where they get the 3 that you see sometimes, but 1 is the number I'm seeing in AC4313. So if anybody asks, how many splices in a wire? I would say, according to AC43 11-167, part C, 1. That's what I would say. Alright, that's it. That's all I got.
Bill Nye.
Bill Nye. Not a fan of his politics, but
Yeah, that guy used to be cool.
it used to be cool back in the day.
Yeah.
Okay,
He's a big baby nowadays.
we're out.
Oh.
Questions? Okay.
Big lip.
If you're following along lab from yesterday done-ish. Today's is a paper lab, or Moodle lab, excuse me, paperwork. Tomorrow would start your actual wire replacement. If you haven't picked a wire yet and you get done with the Moodle section, it'd be a good time to look around and say, which wire do I want to replace? And you can even get started on it